only talk for 30 minutes at a time. So that'll be something to remember. So there is a test, and that is over that chapter 1. These are all multiple choice, at least for this. When we get to our midterm, your midterm is going to be all essay, so the opposite of that. So answer those, and that's your entire week 1. There is a discussion board also that we will sometimes use, but in this case, this would be everything then in week 1. So I will try to organize it by weeks. So we're actually a little behind, so I know we're starting week 2, so I pulled some stuff out and trying to shift it kind of forward a little bit. Does that make sense what you need to do in here? If you have not got Cengage, you need to get it. If you are unable to get it for any significant length of time, come find me, talk to me. I'm not sure how we figure that out, because unfortunately, this is where the book lives, this is where our information lives, and we have it kind of in this platform. So come talk to me and we'll see if we can come up with some kind of interesting plan. I'm not really sure what it is. So what I want to start on then is actually week 2. So week 2, very first thing I need you to do is I need to say, tell me where you are sitting at today. So if you are watching this video, don't do that. This is only for those right in front of me, because I've already got letters from several students who are being quarantined right now. So this contact tracing, I think, is going to get kind of important. We have to turn in our attendance sheets. So if you will go in and say for 824, just tell me what seat number you're at. It doesn't affect your grade. It shows up as like 1 point just because the Blackboard requires a point. But it's just a way I can track who's in class at any day and time. I can't really pass around an attendance sheet. That seems to be beyond that. So every day there will be one of these in there to make sure I know who's where and who's what. Time. All right. So the same thing for week 2. There is a lot of videos in here, and usually they're very short, very sweet. I'm going to try not to waste a lot of class time on them, because you can watch them anytime when you're riding on a bus, driving down the road, whatever it is. You can log in and do that. So again, there's some review questions that are in there, and I tried to put in some things that will let you learn this material. Because this week, the week 1 was kind of fluffy. This week we have some content that is a little tougher in terms of that idea of terms and knowledge. Because this week, as it slowly loads, is we're really talking about hardware and software. And so we're going to have some specific terms that we're going to deal with. So we need a couple of ideas. Yes, sir. They are due by weeks, and they will show up in the Blackboard folder. So I did not put a hard-coded date in there because I figured this semester we needed some flexibility, because I think it's going to be there. So everything inside of week 1 is due by the end of week 2. Let's just say that, so we kind of get it started. I think we're going to have to work around a few things, and I will apologize, because I want to make the live classes are as flexible as we can make them. The online stuff's a little tougher sometimes to deal with. So a computer really has 4 different parts. 4 things that are going on. It takes input, it processes it, churns it, manipulates it, changes it somehow. It stores that data and it outputs it. That's all it really does. So how do I get input? What's an input device? How do I put data into a computer? What kind of things can I use? Well, that's where we store it. How do I put data in, though? Typing. Are there other input devices? Videos would be a type of data. We don't necessarily put video input in that way. What about a microphone, though? Can we talk to our computers now? Can we store data that way? So it's a form of input. Or even if we're creating a video, does that video stream in? I can see where you can come up with that because you're creating a TikTok video or whatever. That's something that comes in. What about a scanner? A camera could be an input device. Our webcam could be an input device. So there's a lot of different ones that could be input devices. So let's look at our computer itself a little more inside there. So no matter whether it's your phone or it's a tower in front of you, it's really got these components in it. It's got something called a CPU, the central processing unit. That's what actually manipulates the data. It's got memory, and that memory stores things temporarily. So if on this computer that in front of you, we pulled the power, that main memory disappears, right? We've all seen that happen. Where most of us are so used to having a laptop and it's got that battery power from the laptop battery that we're insulated a little bit from that. So it's harder to tell what's main memory and what's storage. But main memory is that stuff that's called volatile, or in other words, it goes away. And then input-output devices. So we lump them together, input and output. So what's an output? When my computer's done processing something, where can it display that output? It could be a speaker. What are you guys all staring at in here in two of them? A monitor? Could it be a printer? It could be a Braille reader if you happen to be Braille. It could be the smell-o-vision if we finally come up with the smell-o-vision output. So any way we can put data back out is that idea of input and output. And we kind of lump those together. So now's when it gets a little more complicated. So we have this term bus. And there's no school children on these. They're a set of, it's really just a wire is all it really is. So it's a wire that we're going to use. So we talked about this really quickly. Let me show you their description. So that bus is where all of our data gets sent and received. So on our computer, that's how it goes from the CPU to the memory. That's how it goes from the CPU to the output. So it's all on that idea of this electronic bus. And that bus speed, in other words, how fast that bus runs, tells us a little bit about how fast that entire computer is. Our computers have what they call a clock speed. How many times they can execute something over and over and over again. So right now, our world is so fast. Our computers are dumb. They can only understand a 0 and a 1. But they can manipulate those zeros and ones billions of times per second. So when we say gigahertz, that's a billion times that processor is cycled or started over. So if you think of an engine in a car, and you look down at your tachometer, that's thousands of RPMs, right? How many times it operates in a minute? Now we're talking billions of those in a second. And so our super fast computers are over 4 gigahertz at this point. And so they operate very, very fast. They can move data around, those zeros and ones, really, really quickly. Well, now we also have something that's coming about called multiprocessors. So even on our phones, your new phones have more than one CPU. A computer used to have one CPU. And it could do one set of stuff at a time. And it did it very fast. But now we have multiple processors on most computers. So if I go buy a new Intel i7, it's going to have at least 4 processors inside of that one CPU. So it can, in theory, do 4 things at once. So it is what we call a multi-core processor. So we're going to show you something kind of nerdy on your own computer right here. So if everyone will bear with me, I'm going to get out of my slideshow so I can get to the taskbar. And down here on the taskbar, if I right-click on the taskbar, and I see something called Task Manager. Move it to the window you guys can see. So this task manager, does everybody see where task manager is? Can you get to it? So right click on the taskbar down there and you can find task manager. So you have to be in an empty spot down here. And if you right click, you can find the task manager. Does everybody find it? It says it's restricted for some reason. All right, so bear with me what we'll show you here. So this task manager says these are all the things that are running on my computer. And in fact, mine right now says, hey, you're at 97, 98% CPU usage because I'm trying to record video, I'm saving video, pushing stuff all over. And you can reorganize these columns. It's kind of handy. You could say, all right, I want to see what it is. And notice it's my video recording app that is up there. So this is a really good handy thing. But what I want to click on is the Performance tab. And so in this case, this says it's a Ryzen 3 1200 quad-core processor. Right now, that screen is only showing one processor. If I right-click on it, I can change that graph to logical processors. And notice now it's actually got 4 CPUs. It's showing me how each one works. Some of these computers have 8-core processors on them, as you'll find in the lab. At my house, I have a 32-core processor computer. Some servers are in the hundreds of multiple cores. So they can do many, many things at once. And so I can get away from those speed limitations. It's like a speed limit. We're reaching some limits of physics and limits of laws of nature. So now instead of just having one CPU, we start to have multiples. And so for some things, that means I can spread that load out among multiple CPUs. So that's that idea of multiple CPUs. Like what I use for mine, the reason I have so many is I do a lot of what's called virtual computers. So when I log into my computer, it's under Windows 10. But I also am typically running at least 1 or 2 copies of Ubuntu, a Linux version at the same time. I've got a hacked version of Macintosh running. I've got a couple of other versions so I can run Windows 7 and other things in these virtual environments. And they take a lot of processing power to do that. So the other thing is if you're doing a lot of video editing, which I tend to do, the video editing software is really good about using multiple processors to do that. So where that leads is to that idea of parallel computing. So we can do the same thing on multiple processors. The software has to be able to do it. And in some cases, that software allows us to not only do it just on multiple computers or multiple CPUs on our own computer, but send it out to a group of computers and be able to use all of them. So if you've watched something like Avatar or some of these, a newer movie that's got a lot of animation in it or graphics changes that sometimes you don't even realize that they're in there, they use what's called a render farm. It's not one computer, it's not 2. It may be several hundred setting up as a render farm, and they're all chewing away at that data to try to process it and create that final output. And so that's that idea of parallel computing. We can send it to multiple computers all at once. But again, the software has to be able to do that. And so there is some software. If you're a video gamer, is anybody a video gamer in here? A couple of you? Video games tend to be designed for one CPU. And so the same computer that's really good at doing things over 32 processes isn't necessarily as good as doing it on one process because we typically trade off a little speed to get that many cores. So if you're a video gamer, you may prefer a computer like an Intel i7 with fewer processors than the AMD with the 32 processors or those kinds of things. So sometimes we make decisions and trade-offs based on that. So let's talk about memory, and then we'll give you some time to do some homework and work on some of these things. So memory is where our computer stores things as they're working. The more memory the computer has, the easier it is to do things like open multiple CPU tabs. So if I open up 3 or 4 or 5 or 7 or 8 Chrome tabs, and if you don't have enough memory, your computer crawls to a halt. It's very, very slow, very, very quickly. So this is that working area. So it's like your sheets of paper out in front of you. It's how many of those you have out, how much stuff you can work on at any given time. Well, we said your computer is really, really dumb. It can only deal with a 0 or a 1. That's it. It's called a bit, B-I-T. A computer can only deal in zeros and ones. It is nothing more than a set of light switches going on and off inside of there. To make life a little easier, the lowest capacity of storage that's useful, because 1, 0, or 1 doesn't do a whole lot for us. But when we put them together, and we put 8 of those zeros and ones together, they become a byte, B-Y-T-E. And so that will be something on your final, B-Y-T-E, a byte. So 8 bits becomes a byte. 8 of those together are important, because that's kind of our building block of where we start with data. So, is anybody here a math nerd? Do I have any math nerds in the room? Does anybody, when I say the word math, you try to look down and hide under your mask really quickly? So, can everybody multiply by 2? So if I take 2 times 2 8 different times. So I go 2 times 2 times 2 times 2 times 2 times 2, or 2 to the 8th power. You guys remember those exponents where we said that? 2 to the 8th power, what do you think that is? So we can go through it real quick. What's 2 times 2 is 4. Times 2 is? Times 2 again is? Times 2 again is? Times 2 again is? Times 2 again is? Times 1 more time? 256. All right. So math is hard. Times 2 is hard. 256. What that byte does, so it says I have between 0 and 255, or I have 256 positions, and so I can actually start storing some useful data in that. So I could store the alphabet. How many letters are in the alphabet? Oh, man. How many? 27? I heard 20, 26. So do different languages have different letters in the alphabet? I should have said U.S. English has how many letters? Because guess where this was developed? Here, and so if I were talking about Chinese, though, how many characters does a typical Chinese language have? Thousands. So we'll talk about later how we fix that. But right now, could I store every letter A through Z between 0 and 255? Yeah. So this becomes that first useful piece of storage we have. It's called a byte. B-Y-T-E. You guys see this all the time when you go out and you say, I'm going to buy a computer, and it says, I've got how many megabytes of storage. That's what we're talking about, is 1 unit of data. So it's very useful. Here's where companies lie to you, though. So I said those bits aren't very important because you got to have at least 8 of them before you can even store like a letter, right? When you go buy internet service, how do they think they rate that? Do they rate that in bytes, how many bytes you're going to get down every second? Or do they go, hey, if we said bits, it'd be 8 times as fast? So when you say, hey, I got the latest giga blast internet from Spectrum or whoever it is, and it's 1,000 megabits per second. Because they could sell that easier than they could if they said, hey, it's really, 120 bytes per second. Does that make sense? They can use that to market to you? Yeah. And we're going to show you how they do some other cheating. But a byte, B-Y-T, is the most critical. It's the smallest unit of data that we're going to use. So we have some other terms that you guys may have seen. So there's byte. and then notice it's got 1 in it. If we go to a terabyte, has anybody had to buy a hard drive, or they bought a computer and it said, hey, you have 1 terabyte of data? It's 1,000. Yeah, they say it's 1 gigabyte. Is 1,000 cubed, or 1 billion of those bytes altogether. And we're going to show you how they cheat a little bit. But now we have even bigger ones. So we have petabytes, exabytes, zettabytes, even yottabytes, because we're storing that much data. So the federal government stores huge amounts of data about you. Google stores huge amounts of data about you, and it's putting it somewhere. And these are the terms we use to describe it. So all the way from a byte, B-Y-T-E, that's 1 letter. Then we have a kilobyte. There's 1,000 of them put together. That's a small Word document. And then a megabyte is 1,000,000 of them, right? 1,000,000 bytes. So you could have a small document, a picture. When you look at a phone and you say, hey, this has got a great camera on it, how do we know that it's got a great camera? What's the term that they use? Pixels, but more specifically, they say it's a 8 megabyte or a 10 megabyte or a 12. That's how many of those bytes it's storing. So if I go out and I get the latest, greatest Android phone, so the Samsung S2794 or whatever it is, it may have a camera that says it's got 40 megabytes of storage on each picture. And that's kind of that number that we look at. Now, we're going to look at some other things in here, and I'm going to tell you why some of that is crap. Because does anybody have a digital SLR, a really good camera? Like one of those you pick up that's got the interchangeable lenses? Nobody? Where do you guys take pictures with? Your phone? Got it. So, if I say that the lens on my $1,000 phone is as good as my $7,000 Zukia lens for my camera, are you going to go, but the numbers say it's the same? Do we think that's really true? No. So, we'll show you some of those examples on why things sometimes look much better than they do. So, and if I ever mention prices of anything and you run into my wife, never mention that to her. Because the price I actually paid is not always the price that I tell her what it was. And in fact, I'm still mad at Bailey's mom because she got me in trouble when I bought a new tractor with my ex-wife once. So I went and I bought a tractor for my yard. And I went a little crazy. I bought a $17,000 lawnmower. So it had the digging bucket and a small tractor. Well, your mom happened to see me up filling it up and then ran into my ex-wife and said, hey, I saw your husband had a new tractor. I had had it one day. Small towns are great. So your mom is still on my list for that, Bailey. So this is how we store memory. We're going to get into this much more in detail. What I'd like to do is let you have the next 15, 16 minutes, whatever it is, to go into chapter 1 and try to get as many of those activities done as possible. You should be able to get through at least one. You probably will not get the document where you have to do into a notebook the critical thinking one done, but you should be able to get a good start. You can then save that file off. If you are not able to get into Cengage, is that the case with anybody in here yet? You've got perfect. All right. You just need one. If you have Cengage Unlimited, it is kind of like Netflix, every class. So if you bought multiples for some reason, send it back before you open it or use that code, all right? And there should be hopefully very accommodating to that, I hope. In fact, it's really weird they would let you buy multiple copies, and I don't understand why they even do that. Because you'd think their system would say, hey, you don't need 2 copies of this. But I'm assuming they're thinking, maybe you're buying one for your roommate because you're being really nice. And it could be. So if you can use Cengage Unlimited, you only need 1 copy. So that's why it actually will save money. If you're also taking, the other piece I will throw out, if you're taking a CMIS class in the spring, so you're going to take database or one of my classes, cybersecurity, we're going to use Cengage in the spring. you can actually buy a 1-year subscription and actually save a little more money than just buying it for 1 semester. Now the danger to that is you buy it and something weird happens and we end up using a different platform, or you don't go back to school in the spring for some weird reason, but it's significantly cheaper if you do that. So a great question. All right, any other questions? Anybody confused? Anybody ready for the semester to be over yet? It's week 1. Don't shake your head yet. All right, guys. I appreciate it. We'll give you a little time to try to get that. I know that this semester is a little strange, a little different. Make sure you've went in and told me where you're sitting, and we'll have to figure out some seating. So I may move, depending on when people come out of quarantine. I think we actually have 17 registered for this class. We can only have 15 in the classroom. This classroom gets mirrored to the classroom over here. I know that makes it kind of a second-class citizen, so we'll do some things to try to make that a little better. I will not just set 2 people, so I will grab an entire pod or a group, and that way we can, because that just seems like you're over there all by yourself, like you're the cast-off, right? So, any questions? All right. So for Wednesday, you should probably have read chapter 2, and we're going to start talking about memory. Normally I hand out samples of all kinds of things, but unfortunately we can't do a lot of that today. What I will show you is, hopefully this week, I will get this plugged in. So that giant computer is going to show a camera, so if we have to use the 2 rooms. And this is the computer we're actually going to drive that monitor with. So if I open it up, and I would just normally pass this around. It's not going to want to pop out. The whole computer is in the side of this. That's it. Whole computer. And that's what we're going to use to display content on there. So I use these for a lot of things. These are pretty cool. This is an older model. These are called a Raspberry Pi. And we will see, I'll bring in some newer examples of them also. But that is an entire computer right there. In fact, this one's got wireless, but it's through this. The newest model not only has wireless and Bluetooth, but it's actually a little smaller than this. And that's the entire computer. And they're anywhere from 75 to 150 bucks. This model won't do it. The newest model will actually even do 2 screens like your computer here in front of you. So we'll look at those because I think they're pretty cool, and that's where technology is heading in a lot of cases. All right, we'll let you guys work on that. I know I'm yapping, but let me hit the record button or the end record button, and I'll see if I can get this uploaded in 2 pieces now naturally for you. So if you have any questions,